So I'll start with the incidences, since these are happening a lot, and I think a major one of the reason, of course, when fire erupts, definitely there can be many reasons, short circuiting or whatever. But another reason is the way the urban infrastructure is coming up these days. We have so much of population to cater to, and the way cities have started developing now, without any master plan. It is just haphazard, congested. Things are just coming up. There is no attention paid for fire security or anything. Nothing is paid attention. The buildings are just coming up. So that's why this hazard has become even more of a concern now, that it must be looked into. I'm just sharing some pictures from some, like last year or something, wherein we had these fire outbreak incidences where, not only property but life is also getting hurt. So we are losing property, we are losing life, and definitely it's a very horrific situation to have such a fire. So structures need to be protected, so that people who are using those structures, they can also be uh, protected. So there are so many instances that come to news, and I when I was making this, I was just looking through this, just trying to see how many fire incidences are there. So if I just Google, I could find so many cases which are there on kind of regular basis, that they're coming up. So this really makes us think that as civil engineers, when we're designing structures, so this is a very important aspect that really needs to get its due attention now. Okay. So definitely, even there is database for that as per National Crime Records Bureau. In 2015 there were more than 18,000 cases, about 1,100 people, 1,200 people injured, about 17,000 killed. So if cause-wise analysis of fire accidents are seen, it is concluded that 42% of the deaths were due to fire accidents in residential buildings. So even more alarming. So accidental fires are the number three reason that causes most unnatural deaths in India after road accidents and drowning. So this is of course an unnatural death, and this is a number three reason, accidental fire. And most of them, which have been reported, other than residential, of course, residential building is 42%. Others is in vehicles, in factories and commercial buildings, hospitals, schools. So buildings, structures, they are a big part of basically where these fire incidences are happening. Okay. Now, another reason also is, apart from this man-made structures, even in the natural, environment, even because of climate change, the intensity of wildfires are also increasing. So when a wildfire happens, we all remember this, the picture that I have included. This is for the the wildfire which had come across Australia, which went for quite a long time, and it did a huge amount of harm to the flora, fauna. And that was such a big area. It said almost combined the area of six Indian states: Delhi, NCR, Goa, Sikkim, Tripura, Nagaland, and Mizoram. So that was 63,000 square kilometers. So all these are happening due to climate change. So definitely what has happened to the environment, what is happening, so that is not going to change very soon. So this danger is there upon us. I would say around the clock, this danger is on us, apart from earthquakes and all those things. This is another disaster, which is always lurking on our heads, and it can happen. And when a wildfire happens, even infrastructure gets affected because of that. Okay. So definitely, the occurrences of these fires have become more. They are more unexpected. Their effects have become more intense. So risks have become more intense. So what the risk is happening with the fire, that has to be taken very seriously. Okay. So this is called a fire risk, which is a proper technical term, and this has been ranked as fifth. And from last year's ranking in 2017, recently this has gone up by three positions as the fifth position of a risk which is there. Okay. So when I'm talking of this fire, so what are the issues which are make it such an important aspect to look at? The first thing is, a fire can catch exceedingly fast. That is one thing, that if it starts, it can catch up very fast. And most fatal fires are occurring when people are asleep in their homes. Okay, so many times, most of the times, these fatal fires are when the people are sleeping in their home. So smoke can actually lull a person into deep slumber. Okay, so that is even more. Sometimes people don't even get a chance to save themselves, and the smoke can actually put them into more deep sleep. Okay, so an important question is also whether a fire can damage a structure, but also the question is, when will it damage the structure? That is even more fatal. Now, in night when people are sleeping, and now when that fire occurs, it's even more a concern then. Okay, and most of and what is happening is when exposed to fire, commonly used structural materials, they lose some of their mechanical strength. So there is an issue again now, that even strength wise, the materials are losing some of their strength. And definitely, there is an increased hazard due to tall buildings also. Now there are more mechanically controlled devices around the buildings. There is increased use of combustible materials like furnishings, equipment, decorations, which are made of plastic, synthetics. So I would say these are all like, fuel for the fire. So hazard has of course increased more. There are taller buildings, there are more devices, mechanical devices inside the building which can catch fire. Okay, so the idea is how we can use engineering principles to achieve the requirements of fire safety of structures. Okay, so the idea is, we have to optimize the fire protection to the structures, and also we have to see the complex issue of how the whole structural behavior will happen when a fire comes up. Okay, so there are ways of doing it. What we see in this picture is a test house at the Insurance Institute for Business and Home Safety. Okay, so this is reported by CNBC. This is how they are doing a testing for a real structure, real time testing they are doing for fire in the labs to come up with those engineering principles. So this kind of research also goes around. Okay, so when I talk of fire resistance of building structure, okay, so it is basically the ability of the structure which is exposed to the fire to the appropriate time. For I'm talking of some appropriate time wherein the structure is able to maintain its strength while everything around it burns. So that is the basic definition of a fire resistance. Okay. So that particular structure for a given time, it is able to maintain its strength when it is exposed to fire while everything around it burns. Okay. So it is the property that prevents or retards the passage of excessive heat gases or flames under conditions of use. Okay. So this is another way of looking at it, the fire resistance, that what will prevent or retard the passage of the fire. And fire technically is the heat. So the important factors to see here are what is the rate of heat transfer, and basically what is the combustibility of the material under various conditions such as temperature of the fire, ventilation, fuel sources within the building. So combustibility of material will be different depending on this. Then the precise value of duration in which the construction retain its capacity. So this time period is very important. Even what we say, even our IS 456 is addressing this issue. Okay. So fire resistance means materials and design features, they have been incorporated in the building that will get the ember exposure, will get the fire exposure, but would resist it. So we are saying, we don't say okay, the structure will not face the fire. Okay, this ember is all these particles ye jo, which get generated due to fire. So the structure will get exposed to it, but it will resist it. So we are trying to use such kind of materials, or we are trying to have such design features. So that's what we are going to discuss. Okay, so if I have to build a fire resistant structure, okay, so I have to have some built-in prevention also that will help me. Then I can have some active automation also, like the sprays and everything. And of course I have to have a planned passivity, how to make it how to tackle it in a passive way. Okay, so all these three parameters together can give a reasonable resistance. Okay, so one, when I'm talking of structurally, the idea is, one is resistance to collapse, which is the load bearing capacity. Okay, so which will apply to load bearing elements. Then I have to look at the integrity part, which will be resistance to the fire penetration. Okay, and the third aspect is the insulation, whereas the resistance to the transfer of excessive heat. So these are the three measures with which we can say the fire resistance can be designed. Okay, one is resistance to collapse, then integrity, and then insulation. Okay. Since we've all been saying that it is for a specific period when it should be able to resist it. Okay. This duration of time, it is determined by a fire test, and a method is based that a building element, component, or assembly, it maintains the ability to confine a fire and continues to perform a given structural function or both the tasks. So that is defined as the period. So there is a proper test which is conducted by which we know, okay, the thing was able to confine the fire and still be able to perform structurally well. Okay. So when I'm doing a fire analysis, the calculation will account for the actual technical state of construction, the material exposed to the thermal impact of fire load. Okay, so what is the type of construction that happened? Okay, what is the state of it? Then you will be provided with a critical temperature, that is the temperature to which the structure maintains its capacity, or advise you of the optimal fire protection of the structural elements. Okay, so the idea is that I take into account the construction material, the stage, and then I'm able to suggest the period and the time within which the structure will maintain its integrity, insulation, and capacity. Okay, so building regulations require that there are certain elements of a structure which are supposed to have a fire resistance. Okay, so it is required that some elements, they have to be fire resistant. Okay, now how are these determined? Okay, so that will depend on the building size, the building use which is being put to the use, the building, and the function of the element. Okay, so what I do for the design of structures when I'm designing for fire resistance, I have three steps. I first of all determine what is the design fire, which means the fire that it may be exposed to. Just like, when I have to design for dead load, there are some design dead loads for which I design. Okay, so this design fire is in terms of temperature time relationship. Okay, with time, how much the temperature will go high. Then I do calculation of the structural temperatures, the material, what temperatures it will reach. And then I assess the load carrying capacity at this elevated temperature. So that is very important. So you'll actually come across a lot of research people are doing in this area at elevated temperatures, how the material is behaving. Okay, so that is actually picking up a lot these days. And there's a lot of research going on, and you'll be able to find good papers in good journals. So when I talk of codes and standards, okay, so in India, the first most important standard in this relation would be IS 1641, which is for fire safety of building, general principles. Then our NBC Part 4 is also taking due consideration of this. Then we have NFPA 557, which is for determination of fire loads, and then 551 for evaluation of fire risk assessments. Then even British codes are also there for evaluating capacity of structural members at elevated temperatures. And many times, BS codes, these British standards, are quite in like similar to our IS standards. So many times British standards are also referred to. Okay. Then we have IS 2190. Okay, so how about fire extinguishers, and also 15683. Okay, so it's very important to know which codes are applicable. Okay, now talking of the fire load. Okay, so fire load, when we are doing it, is basically the amount of heat in kilocalories which is liberated per square meter of floor area of any compartment by the combustion of the contents of that building and any combustible part of the building itself. Okay, because what is inside the building, that will burn, and what is the combustible part of the building itself, that will also burn. So all these together, how much heat in kilocalories is liberated per square meter of the floor area. So that is now defined as the fire load density. Okay, which is basically what you see here. It is calculated by a formula which is depending on the floor area, total mass of combustible material in kgs, and what is the calorific value of that. Okay, so we are, of course, when we are using this formula, we are assuming that the materials are uniformly distributed throughout the building, and and of course that all the combustible material will be undergoing combustion. So that's the assumption we are making. Okay. Now, in terms of fire load, also we talk of movable contents. The combustible furniture, equipment, goods, supplies. Okay, all these which are movable. Then there are interior finishes like exposed combustible materials permanently fixed to walls, ceilings, floors plus doors, trim, built-in fixtures. Okay, so these are interior finish. Okay, so these two things are basically contributing towards the fire. And then the fire load sometimes is also called the fuel load. Okay, so basically what we do, all weights are converted to equivalent weights of combustible having a calorific value of 4700 kilocalorie per kg. So many times this value is adopted as a general assumption, as a safe number, that whatever weight is there, you assume that everything together has 4700 if you don't have individual. So as an average, this number is adopted very popularly. Okay. So basically, the fire load is important because we use this value as a basis to have an occupancy grading. Okay, so because based on the fire safety, so grading is given to the various buildings. So how much occupancy it can take, that is depending on this. Okay. Now, of course, we have to understand, because if the compartments are larger, they will generate higher temperatures. There will be more, radiation from it, and they will have higher burning rates. So this becomes very important to understand this number. And of course, the different thermal conductivities of enclosing walls, they become important. Okay, so where radiation is dominant, thermal inertia, that becomes important. But then later stages, when heat conduction loses predominance, thermal conductivity becomes more important at that time. So earlier stages, of course, it is the radiation, the waves, the rays that are, heat rays that are coming out. Okay, so then later, then thermal conductivity becomes important. Okay. Of course, that many times, another factor to consider is that many times there are early or pre flashover stages of fire growth. Okay, so if we talk of a high complex and hazardous entities, okay, so this number is very important. Okay, so when I'm talking of early fire growth, there are important parameters such as the what is the amount, what is the surface area of the combustible materials, how are they arranged. Okay, then how are the openings in the walls, ceilings, or doors, and what are the local zones of hot gases. So these are very important to evaluate if there will be an early fire growth. Okay, and of course another effect that comes in is the wind effect on high rise building. It incorporates into the design fire as an important criteria, because when wind is blowing in high rise buildings, it will definitely add to something. Okay, to the smoke. And smoke will, of course, also spread radially from the central axis of the plume to the higher positions. So, wherever this fire is generating from the central axis, the smoke will spread radially into higher positions. Okay. So, then cool air will be entering towards the burning fuel at the lower levels of the building. So, this is how the fire will keep spreading, and that is unnecessary to understand. Okay. So, also as per a study which was done a few years back at IIT Gandhinagar, okay, so modern day buildings in India is three times greater than what was even as late as 1990s. Okay, so the number of buildings have increased. Then we have corrugated plastic roofs, partition walls, plastic doors, false ceiling panels. We have interior finish material. Then equipments like washing machines, refrigerators, air conditioners, all these gadgets and everything, they have also increased. Okay. So definitely the fire load energy density, another term FLED, which is around 1400 megajoules per square meter. It is three times the average of 487, which is found during the study done 20 years back. So the value, in just 20 years has become almost three times, that fuel that we're talking of fire load density. Okay. And also it has been found that the maximum expected temperatures have also increased in the last 20 years. Okay, so things are only getting more and more risky, more number of buildings inside the building, more fire load also, and even the expected temperature has also increased. Okay, so basically, NFPA standard 557 proposes that the fire load calculation should be done by either weighing or the inventory technique, or a combination of both methods. So there are two methods that they are proposing, or a combination of both. Okay. So in the weighing method, what is done is based on the weights of the combustible and the corresponding calorific value of the material. So you just convert them into units and you get the megajoule unit. Okay. Weight into combustible value, calorific value. Then inventory is based on the measured volume of items. Okay. So then weight is obtained by volume into density. Okay, pre-weighted items not used and no direct measurement of mass is done. Okay, and similar to direct weighing, then you use into various calorific value and you can get their corresponding heat values. Okay. What is done in combination of both. So it uses data from the direct weighing method and inventory method. So weights we are doing by directly weighing or pre-weighed, or we do the dimensions volume and convert with density to volume, and then finally go for the calorific value and the heat generated. So basically what inputs, if as a designer we are trying to do, so we should know what is the layout. Okay, so major compartments, unit blocks within the facility, what is the inventory of the material, what kind of material is there which can contribute towards fire load. Okay, then any situational or seasonal impacts of the inventory, in this time of day it will be there, it will not there, then site observations if any. Okay, so when I'm doing design of member, okay, so there are, this is how we can go about it. Okay, so basically we determine the reduced cross section corresponding to 500 degrees Celsius, then obtain the material property at that temperature, calculate the rebar temperature using penetration due to fire, and then determine the reduced moment capacity. Okay, so many studies have been done, and we can see here people are showing how in case of fire, how the various resistance capacities, how they are changing. Okay, so basically that's how we are seeing that in case of fire, if otherwise what you required was 342, for a fire resistant you require at least 381. Okay, so that's how it is done, and this pair table is showing fire resistance rating of beams. Okay, so when they did, okay, so rating can be given for 2 or 3 hours. So that is the time period for which we were saying that it will maintain its integrity, collapse, and insulation. Okay. So when I'm designing a structure which is exposed to fire, what I do is a structural design at normal temperatures, then in fire conditions. I should know the material properties in fire. Then I design the individual members which are exposed to fire, and then the entire structural assembly also. Okay. Uh, Talking of fire hazard, the classification is basically into three categories, okay, which is light, ordinary, and extra, low, moderate, or high. Okay, so in case there are class A combustibles in minor quantity and class B flammable liquids which are less than 4 liters in quantity, which are defined, there are then solid combustibles and flammable liquids, solids like paper, water, wood, cloth, and plastics, and flammable liquids like alcohol, ether, oil, gasoline, grease. Okay, so which can be extinguished by smothering. So these are the two class of things, and based on the quantity in which they are there, so the classification is done for the hazard. And then also classification of buildings depending on the character of occupancy, whether it is residential, educational, institutional, assembly, business, so the groups are defined, and there's one even hazardous, J. Okay. Then another thing which is important is IS 1641 is dividing the nation into zones. Okay, so basically the concept is that there has to be a demarcation. So the city or the area, it should be demarcated into distinct zones based on the fire hazard which is inherent in the building according to occupancy, which are called the fire zones. Okay, so when I'm doing development plan, land use development plan of the city, I must take into consideration in this fire zone. So if something is at a higher fire hazard zone, so I have to plan my buildings accordingly in that area. Okay, so mostly zone one, what is there, that should have residential, educational, institutional, all these mercantile buildings. Okay, which are under development for such occupancies. Then two can go for divisions and industrials, and then three then basically goes for high hazard and industrial. So accordingly the requirements are met. Okay, so then what the code is then telling is that once the fire zone is determined where that building can go in which zone, then the type of construction, it is defined by the code, and you can go for these types of construction. They have defined the construction type 1, 2, 3, and 4. Okay, so NBC, talking of construction classes. Okay, so there are four classes according to NBC, which is based on the resistance offered by building components for 4 hours or 3 hours, 2 hours, or 1 hour. So that accordingly they give type 1, 2, 3, and 4. Okay. So again, as we said, keep in mind the structural components, they should be constructed so that materials, they can withstand fire as an integral member for the desired time period, and it can in this time there should be enough time for the occupants to come out, and the building should not collapse during this time that we are specifying, 1, 2, 3, or 4 hours. Okay. So once we've done the fire load calculation, then next what we do is the fire risk assessment. Okay. Which is basically, the idea is, it is an approach wherein we're trying to detect, prevent, and mitigate any hazard or condition that will lead to fire at a particular building due to activities carried out in the premises. Okay. So what we do is a fire risk assessment. Okay. So the idea is to investigate the likelihood that the fire could start and cause harm to those in and around the premises based on the existing fire load. Okay. And then coming to now next, how to give the fire protection. Okay, we have a design for the particular type of construction that is given there. Okay, according to the code, we have the fire load calculation, go for the construction fire zone and everything. And then now coming to how we can, apart from design factors, how we can give fire protection also. Okay. So the idea is that we have to save life and property, minimize the interruptions of surface due to fire, and we have to mitigate the unwanted effects of potentially destructive fires. Okay. So, of course, we have to understand that no practical building material is truly fireproof. Okay, well-constructed houses and buildings can prevent such tragedies by using materials that are relatively fire resistant. Okay, so everything cannot be fully fireproof, but the way we construct, the way we yeah, plan our buildings, construct our buildings, so we can at least have a relatively fire resistant building. Okay. So this is just giving an example, how we can go, so if we are talking of these eaves, this eaves, they can be non-combustible material. Okay. So so that along the eaves the fire doesn't spread into the house. Then roof material, okay, so here if we have non-combustible material, so that is good, then fire will not leap. Okay, then we can have fire alarms, we can have outer walls which are prevented, then partition walls. We can have this shutters, in case they are there, they can be fire retardant, fire prevented. Then ceilings, they can be looked into. Okay. Now, talking of fire-resistant construction of walls and columns, okay. So, one strategy here is to make thicker sections, okay, so that they can resist fire for longer time and also act as barrier, so that the fire doesn't spread to adjoining areas, okay. So, if walls are to be made of stones, granite, and limestone, they should be avoided, okay. In case of frame structure, RCC should be preferred to steel, and if steel is to be used for frame structures, the steel structure should be properly enclosed or embedded in concrete or terracotta or brick, gypsum, plasterboard, any suitable material. Okay. Then walls of lightweight concrete are preferred to dense concrete as far as fire resistant qualities are concerned. And if the frame of work is of RCC, then thicker cover should be given so that members can resist fire for longer. Okay, generally 40 to 50 cover for columns and beams going up to 35 to 40, and for slabs about 25 Okay. Then partition walls should be of fire resistant material like RCC, bricks, hollow concrete, clay tiles, okay, asbestos, cement boards. Okay. So 20 centimeter thickness of common wall, okay, is sufficient from fire resistant point of view, but it should be raised above the roof level by at least 90 centimeters. Okay. Clay wall has better fire resistance. Okay. We can have a fire resistant mortar on the walls. Okay. In case of solid load bearing walls, bricks should be preferred to stones. Okay. Wooden partitions, in case they're employed, they should be covered with metal lath and plaster. Okay. Even a cavity wall is a good resistant to fire. Okay. So fireproofing treatments for column and steel trunks, this is what it is showing. Okay. So minimum cover, and then how we can enclose it in the gypsum plaster board or other things. Okay. This is the wall thickness which is given by the various codes, okay, for different hours that you're trying to have. So how much thickness of the wall is required. So the first one was for bricks of clay, concrete, or sand lime, then concrete blocks, then RC. Okay. Then for hollow block construction also, they are giving the minimum thicknesses, each type of blocks. So all these details are very exclusively given in the course, so they must be properly interpreted and used in the design. Okay. Now, after columns and beams, coming to floors and roofs, they are also important. Okay, since they are the horizontal barriers which will prevent the spread of heat. Okay, then if the slab roof is sloping or pitched, that is always better. Okay, so trusses should be either of RCC or protect rigid steel and fireproof covering. Okay, if you have thin timber for the floor. Okay, so thicker joist at a greater spacing should be used. Okay, so fire stops or barrier should also be provided. So materials for flooring like ceramic tiles, bricks, they are more suitable for fire resistance. Okay, so covering, of course, the iron parts and everything, core, carpet, rubber tiles, give them insulating material coverings. Okay, then ceiling directly suspending from floor, they should be a fire resistant materials like asbestos. Okay, they should be directly attached or suspended from the floor joist. Okay, so try to have them fire resistant. Okay, this is one drawing, fire resisting hollow tile drip floor, okay, which can be given for various finishes and everything. This is one detail which is for the concrete jack arch floor, right? Coming to wall openings, okay. So what we want is that from the wall openings, the fire spread should be as least as possible. Okay. Now openings are a means to escape, so they should be properly protected by suitable arrangements in case of fire. Okay. So otherwise they will become a passage for fire instead of for escape for people. Okay. So if we are providing solid timber doors, minimum thickness 4 centimeter. Wire glass panels are preferred for windows. Rolling shutter doors should be used for garages, shops, and in case timber door, minimum thickness should be 4 centimeter and door frame 8 to 10. Okay. So windows, if carried down the floor, they should have a suitable barrier. Okay. Then also opening should be used for communication. They should have double fireproof doors. Okay, any window you have fireproof shutters. Then any structure has a separation less than 6 meters from adjoining structure. They should be made fireproof. Okay, then free circulation to persons in passages, lobbies, that should be given at all escape doors. Okay. Then escape elements such as staircases, corridors, lobbies, entrance, they should be constructed of fire resistant material. They should be separated from the building. They should be fireproof. Doors to these escapes, they should be fireproof. Okay, so staircases should be located next to the outer wall. They should be accessible from any floor in the direction of flow towards the exit, and they should be fixed in such a way so that they make them close from inside only. Okay, so that easily, if it is required, it can be closed from inside. Okay, so that will help the people to leave and evacuate the building safely. Okay, so all these things are very important when we are planning our buildings. Then lift shafts, then enclosure walls, they should have a fire resisting material. Okay, they should be vented from the top to permit escape of smoke and hot gases. Emergency ladder should be there. Then all routes with railing balustrade, then they should not be less than 1 meter height. Then internal stairs, there are various types of requirements for that also. Okay, how they should be placed, they should be insulated. Okay, so wherever possible, go for a straight flight. Okay, minimum clear width should not be less than 1 meter so that people don't panic, they have enough space to go out also. Okay, fire escape, again, minimum number of risers and everything, what should be the height, what should be the slope, everything is given even for spiral stairs. Okay, then in case we have steep ladders which will be used in the building, okay, that can be used for a low density of population. Okay, so where fire escape stairs or spiral stairs are not practical, then we can go for steep ladders. Then how much should be dimensions for them, that is also specified. Okay, so basically when I'm planning for fire protection, So I need to have three important aspects in my mind. First is detection. We should be able to detect that the fire has happened. Then there should be a signaling, okay, that the signal should go that yes, the fire has happened, something needs to be done, and then we should be able to suppress the fire. That is also very important, okay. So presence of fire should be known. It should be detectable manually or automatically. Then buildings management, occupants, fire department, they should get notified of the presence, and then the equipment system should be there to extinguish the fire and remove the smoke, okay. So our initial effort will of course come from the portable and manual firefighting equipment such as fire extinguisher, fans, first aid fire hoses. Then main effort will be fire suppression systems such as automatic sprinklers, fire hoses, okay. And then last effort will be the fire department, which will take on the firefighting effort when all previous efforts are ineffective. Okay. So for fire detection, of course, we have a lot of equipment which is available. Okay, this is a common residential smoke detector. It sounds an alarm when smoke is detected, so that it can initiate an egress. Okay, so these are smoke or heat sensors. Okay, they can summon emergency services also. Okay, so there are two types: addressable and conventional. Okay, addressable specifically, it is monitoring some location of each device. Okay, so in case of a fire or other emergency, you know exactly where the problem is. So that saves precious time and helps the emergency services prevent the loss because they know specifically where the fire has happened. Then conventional systems only alarm for a problem in a general area. So they are suited for small sites. Okay. Then fire prevention may we can also go for hypoxic air fire prevention. Okay, oxygen reduction systems. Okay, so they can be done as an automatic system also. They reduce permanently the oxygen concentration inside the protected volume, so that ignition or fire spreading cannot occur. And at lower altitudes, hypoxic air is safer to breathe for health individuals also. Okay. Then, if I talk of active measures and passive measures, so active measures will be the items or systems which require a certain amount of motion and response in order to work. But passive measures are there which are always working, you know. So fireproofing, fire stopping, or some conditions on occupancy be put so that fire can be prevented. Okay. So the idea is to construct a building in which fire would take place slowly, which will allow occupants plenty of time to escape. So fire suppression measures, we can have fire blankets. Okay, so they are made of Kevlar or fire fiberglass. Okay, so laboratories, factories, they generally do have it. Then fire extinguisher, the common one is ABC type, so it can be used for normal fires, liquid fires, electric fires. Okay, so special according to type, they are there. Okay, then manual fire suppression standpipes, which we have seen in most of the high-rise buildings. Okay, multi-story buildings they have it. They can be dry or wet. Okay, so most of them are dry systems and they cannot be used by the public. So a fire engine is required to pump water into the system. So most dry systems they don't have pre-connected hoses and require firefighters to bring in the hose. Then wet system there is always water in the pipes and it can be used by anyone. Okay. Then automatic fire suppression, if you want to do that. Okay, so what we are trying to say is that no human intervention will be required. If a fire occurs, automatically these suppression measures will come into play and suppress the fire. So one example of this are the sprinkler systems. Okay, so very critical places they are definitely provided. Okay, so they sprinkle water. Then another is also a gaseous clean agent. Okay, so when there is water or dry chemical extinguishing agents, so that will do more harm than good. Okay, but they cannot be done where there we go for gaseous. Okay, say server or computer rooms, or a system works by flooding an area with an inert or a mix of inert gases to break the fire tetrahedron. So we actually fill the place with a gas. Okay, so due to inert gases displacing oxygen, there is suffocation risk which is activated. So definitely we don't want people inside when this measure is taken. Then there are also foam suppression systems. Okay, low expansion, medium expansion. Okay, the foam expands, and that's how the fire is extinguished. Okay. Then high expansions are also there. Okay, they can go to 200 to 1000 times of the original size. Okay, so they quickly fill up the space and cut off the oxygen supply. Okay, then talking of fireproofing, then that is rendering something resistant to fire or incombustible or material for use in making anything fireproof. Okay, so whether I'm talking of structures, materials, I'm trying to make them resistant to fire or incombustible. Okay, so where do I need it? Structural steel, I have to keep it below the critical temperature of 540 degrees Celsius. Electronic circuits, they have to be kept below the critical temperature of 140. Okay, then LPG containers, so that I don't want a boiling liquid expanding vapor explosion. So fire protection is very important. Then pipe bridges, vessel skirts in oil refineries or chemical plant, they have to be kept below this 540, and concrete linings of traffic tunnels. So all they require fire protection. Then fire blocking in a wood frame construction, gaps are created by joist or studs in floor or wall partitions. They allow fire to travel easily from one area to another. So that is another way to do it. Okay, then instantly internally divide these areas into smaller intervals. Okay, so we go for common lumber, plywood, OSP, so that we divide them into smaller parts. Okay, so firewall, this is a common method. Okay, when we separate the building into smaller units to restrict or delay the spread of fire from one section to the next. Then fire barriers and fire partitions are similar to firewalls. Their height is limited to single floor. Okay, then many times you're putting a seal around the openings and between joints in a fire resistant rated wall or assembly. Okay, say I have a linear gap between a wall and the floor above. So in order for construction to form a complete barrier to fire and smoke spread. Okay, so many times you're giving these kind of seals also. Okay, like what we see here, this is a fire stop mortar seal which has been given above the cable tray. Okay, this is another thing of a fire stop. Okay, another drawing which is showing how we can break a firestorm. So basically, idea is prevent unprotected horizontal and vertical penetrations in a fire-resistant rated wall. Okay. Then electrical, mechanical, unpenetrated openings, all junctions between fire-resistant wall, head of wall, all these places, fire protection is required. Then many components of fire protection, many times we are using intumescents, we are using cementitious mortars, silicone, fire stop pillows, mineral fibers, rubber compounds. Okay, so all these things they are shown in the picture here also. How we are using all these things, rock wool and everything. Fire tests are done on them. Okay, so in case I have to, making new electrical installation of cables and everything, so then a fire rated barrier has to be done as a fire stop. So I need to, put a fire stop all at all these places. Okay. Another thing, a conflict with fire stops and firewalls should be avoided. Okay, so spray fireproofing of structures steel is best accomplished before interior partitions are built. Okay, so that there is continuity. What we see here on the right side, because spray fireproofing was not done properly, so there was penetration into the cover. Okay, this is also an example of an improper fire stopping, if you can see here. Okay, so we have to take care of the quality aspects also. Then also, when we talk of fire tags, fire stops, tagging is very important. Okay, so proper maintenance by installation of tags on each side of the fire stop, so which is needed to refer to the documents indicating approved procedures for original installation and re-entries. Okay, so certification is being done from time to time that it has been inspected, it is working. So these tags help. Okay, so fire stop materials, they are not rated per se, but they receive a fire rating by combining materials in an arrangement specific to the item, a pipe, cable, for example, penetrating the fire rated wall or floor. Okay. So a 2R rated pipe penetration fire stop may consist of a layer of steel joint over packed rock wool. Okay. So that can provide a 2 hour rating. So these kind of things, people try to combine and have innovation and have maximum results. Okay. So and this is showing just things which should be avoided, so that there is no breach of fire resistance. Okay, another picture. Okay, So all these kind of things. This polyurethane foam is being used to fill a cable tray penetration. Okay, then a fiberglass insulation. Okay, so just take care that it will rapidly melt and fall out in a fire. So be careful which material you are using. Okay. Now talking of various materials. Okay. Even materials themselves, they are rated in respect of how long it will take fire to affect its structural abilities. Okay, so for fire resistant structures, of course, this time will be longer. Okay, even heavy timber can be considered fire resistant. Okay, it is combustible. However, metals like aluminium, steel, they aren't combustible. Instead, they tend to buckle under intense heat. So everything has its own parameters which must be looked into carefully. Okay, so fire resistant qualities of a material, they are very important. So they determine how well the structural integrity will be maintained when exposed to intense heat and flames. Okay. So asbestos is one material historically which has been used very popularly for fireproofing. So fire, it can be used on its own or together with binders such as cement in sprayed form and press sheets. Okay, so additives to a variety of products and materials. Okay, building materials, fabrics for protective clothing. Then, but later on, it was seen that it is causing cancer in the long run. Okay, so there are various endothermic materials like gypsum, concrete, and other cementitious products. Then fire-resistant materials, when we talk of concrete, stucco plasters, gypsum, brick, they're all known to have good performance. Okay, stucco is a plaster that has been used for a long time. It has good aesthetic value also. Okay, so modern stucco is made of Portland cement, sand, and lime, and excellent and durable fire-resistant finish material. Okay, for brick and wood, we can cover with this. Okay, two or three coats. So all these things, it can give at least 1 hour of fire rating to a wall. Okay. Then gypsum board, which is drywall, which is very popular in Western countries with their type of climate and everything. Okay, so it is being used very extensively and very successfully in multiple layers. Also, sometimes it is used. Okay, so since bricks are they are made in a fire kiln, so definitely inherently they are highly resistant to fire. Okay, then individual bricks are much more fire resistant than a firewall. Okay, so because in a wall we have the mortar which is coming in between, it is less effective. Okay, so so depending on the construction and thickness of the wall, a wall can achieve 1 to 4 hour fire resistance. Okay, now, windows, even before in direct contact with flames, the intense heat of a nearby fire can cause the glass to break. Okay, so then a broken window will allow flames to enter a building easily. Okay, and then heat from a fire outside might be enough to simply ignite flammable items inside the home without direct contact. So windows are very important part. We have to really take care of them. Okay, so. The window framing, go for steel, wood, or aluminium. Vinyl is not a good option. Dual panel glass, that will double the time for fire to break the windows. Okay, the outer layer will break before the inner layer. Then tempered glass, which will go up to 500 degrees Fahrenheit. It is heat treated, that is more stronger, almost 4 times. Then we even go for glass blocks. Okay, then there are fire rated glass which are there which can even survive 1600 degrees Fahrenheit. So wired glass which has tempered glass with metal wire reinforcement, ceramic glass, specially tempered glass, transparent wall units. Okay, so fiberglass doors, all these kind of things, they are good options. Okay, then there are many plasters which are available, okay, like gypsum plaster, cementatious, fibrous plasters, flame retardant plasters that are put up to have better fire resistance. Okay, then there are lightweight plasters which are consisting of gypsum or cementatious materials, fibrous materials. Then there are calcium silicate boards, okay, proprietary boards and sheets made of gypsum, calcium silicate, vermiculite, perlite. So these are all very common materials which are popular. So there are special boards which are available which you can use, like they have shown here. So you can easily use boards to insulate important materials like that to cover them. Okay, then. There is also a concept of thermal break, So idea is it is manufactured from non-combustible components. So definitely where you need fire rating above 18 stories for buildings more than 18 stories. So this is a good thermal protection. It also act as connectors from steel to concrete. So it is made from Ancon STC20. This is one of the material which is available in the market. Okay, so this is a steel to concrete thermal break. Okay. Then intumescent paints are available. Okay, they are the cheapest fire protection alternative. You put up a thin layer, maintain the original appearance of the steel structure also. They are aesthetic also, and they can be applied in the workshop or on site. Okay. Then thin layer paints, they can be water based or solvent based. Thick paints based on epoxy. So they are hydrocarbon fires. So they can be very effective. Okay. Then fire stopping sprays are there like cement fiber, vermiculite, plaster. Okay. So where aesthetics are not very important, you can go for such kind of sprays also. Okay. Then when I'm coming to fire protection slabs, okay, so you can put up slabs, say these eye profiles, they have height greater than 450, then so that you put up this fire slab over it so that it is protected. Okay. Then there are these RHS profiles also. Okay. So they are rated for the fire, they're like they are given here. Okay. So many companies are offering these kind of products also. Okay. Then going for fire resistance rating, okay, that's another parameter. Like yesterday we were talking of load rating of girders, beams, or bridges. Similarly there is fire resistance rating also. So the idea is it is a measure of the time that an assembly will withstand the passage of flame and smoke and the transmission of heat when exposed to fire under specified fire conditions, including structure load if applicable. Okay. So, based on ISO 834 fire resistant test, elements of building construction, then there are ASTM standards, identical fire exposures prescribed in two standards. Okay, so all these kinds are they are giving the fire resistance rating. So basically, the idea is they are using various time increments to correspond to the length of time the material should be expected to perform reliably in a fire. Okay. So basically, if a product has a 45-minute rating, theoretically you can count that containing flames and smoke for the first 45 minutes of a fire, it will be able to contain it very nicely. It won't spread before 45 minutes. Okay. So once the product has completed the rigorous test process, it is assigned a fire rating. So it can range anywhere from 20 minutes to 3 hours. Okay, so building codes they dictate that where the different rated products would be allowed in a building. Okay, so they have to account for how long the time can be given safely to people to exit the building. Okay, so basically, when I'm talking of glass, okay, so basically how they do the testing of the glass, okay, they fix it to a wall, okay, follow a strict time or temperature curve. The heat is in the furnace is raised to an intense level. Simulation conditions of the building, they are trying to simulate that. To pass the test, the glass must remain in the flame. Okay, cracking is allowed provided the glass can still act as a barrier to flames and smoke. Then in the second test is the hose steam test, which is basically the idea is to demonstrate that the glass can withstand thermal shock. So a fire hose with a pressure nozzle which is very high pressure. So it is brought close to the hot glass with water at a pressure of at least 30 pounds per square inch, and then to cover the situation of sprinklers coming during a fire or if fire extinguishers arrive. Okay, so that's what we're trying to cover. This tests whether the glass has the integrity with the system and surrounding material. Okay. For masonry, we generally do a fire endurance test. Okay, so the host team test subjects a specimen to impact, erosion, cooling effects over the entire surface area. Okay, a superimposed load is applied to bearings. Specimen applied load is required to be maximum load conditions, and columns are located to simulate the maximum load condition, which are recognized by the design criteria. Okay. So there are various acceptance criteria which are given. Okay, that how much kind of temperatures cannot be exceeded, what kind for various barriers So those are all given for various types of structural elements, bearing, non-bearing walls for columns, that the inflator should not exceed this kind of value. Okay, so this is one excerpt from NBC. Okay, so that, as I said, they are telling different types of constructions which are allowed for a given situation: exterior walls, fire resisting walls, enclosure, shaft, all these kind of things. So basically, when I have to go for a fire safety design, I should have a fire resistant construction, first of all, then vertical openings, adequate lighting, coordination with fire department, then vertical transportation should be possible, coordination with mechanical, electrical, compliance with the code for specific use groups, exit enclosures, then means of egress, length of travel, and the smoke controls. So all these have to be kept in mind. Okay. Now, NBC, like this is the clause 4, so they are talking of life safety, fire safety, what should be occupant load, capacity of exits, and everything. So they should all be referred when you're designing. Okay, so even for staircases and everything, what kind of handrails, blusters have to be given. So the details are mentioned. Okay. So basically, when I'm talking of fire and heat, so important terms are fuels, combustion, fire initiation, burning objects, pre-flashover design fires, heat transfer. Okay, so these are very important terms which must be read from NBC. Okay, so for concrete structures, when I talk of them, okay, so they are strong and most durable when I talk of this fire resistance of materials. Okay, so basically cement, which is limestone, clay, and gypsum and aggregate, they are chemically inert and therefore virtually non-combustible. Okay, so basically the exact fire resistance property will depend on the amount of aggregate used. Okay, natural aggregate tend not to perform as well, but moisture in the aggregates can expand when heated, causing concrete to sinter after long exposure. Okay, and concrete also has a slow rate of heat transfer, so that's why it's a desirable material. Okay, so basically, this World Trade Centers, despite the intense heat of burning jet fuel when the planes hit these buildings, okay, so they had a 4-inch, 10 centimeter concrete slab between each floor of the towers. So they were able to limit the spread of the fire for some time at least, okay. But since the tower walls were framed in steel and other materials, not concrete, okay, so the heat of the fire topped when it topped 800 degrees Celsius, a degree Fahrenheit, the tower supporting steel structures weakened and that became to collapse. So concrete is definitely a better option. Okay. So concrete can generally withstand up to 4 hours of extreme fire. Okay. And most wooden frame, they won't last even for an hour. Okay. Plus, when concrete burns, it does not emit any toxic fumes. It doesn't produce smoke. It doesn't drip molten particles. Okay. So even fire resistant structure material, it is a very cost effective also. Okay. Often rated for the best fire rated roofing material also. Okay. Uh, Definitely, as I said, inherent construction materials, structural design, overall design, robustness, all these things, as I had mentioned earlier, also in first lecture. So we are trying to these days design for robustness. That is, we don't want progressive collapse. Okay, so concrete can help with this. Okay. So just this is telling that OPC can even stand fires up to 300 degrees Celsius. Okay, so after 600, of course, it's not very desirable, but it's a good material. Okay. Uh, so if we can use some constituent materials like special plastic fibers, special aggregates, special sands, high alumina cement, okay. So all these materials, they can help making concrete even better, okay. Special aggregates, if we can use like carbonate, like limestone, lime, rock, dolomite, aggregates without silica, lightweight aggregates, they will of course help in increasing the fire resistance. Then fibers like polypropylene, monofilament fibers, all these kind of things help. Okay. What we can do for other passive measures, using heat shields that is coated with intumescent paint. Okay. Coating or sealant swelling up when heated, thus protecting the material underneath or sealing a gap in the event of a fire. So that's an intumescent material. Okay. So basically, the key aspects basically is of course we don't want spalling of high strength concrete, temperature movements, and calculation fire resistant ratings. All these things should be looked at. Then how do you want to anchor reinforcement during a fire? Effective design, fire safety, design methods for beams. All these things are very important during design to be considered. When I'm talking of steel, okay, so steel basically what happens, the core ingredients, they are fire resistant. But what happens, the heavily loaded steel will lose its design safety margin at temperatures around 550 degrees Celsius, regardless of the grade of steel. So that's a concern that when it is heavily loaded, the temperature exceeds 550 degrees Celsius, it will lose its margin of safety. Okay. So, of course, for fire-resistant design in steel, many interventions have been in terms of design, material behavior understanding, construction, maintenance. Okay, so there is a prescriptive approach earlier wherein we have fire protection thickness from tabulated data to achieve the prescribed fire resistance rating. So that much thickness of material has to be given. But now what is done is we have a quantification of structural performance under fire conditions based on first principles. So we optimize the fire safety resources, we improve the fire safety. Okay. So we are trying to quantify what will be the structural performance. Okay. So Eurocode is one of the pioneers which is dealing with this in a very proactive way. Okay. So they are giving all the requirements. What should be the structural fire resistance design, construction. Okay. Material properties at elevated temperatures. They are giving design loads and everything. Okay. Then tensile membrane action, okay, in floor slabs and concrete filled tubular columns that is desired. Steel framing for steel fire resistance, concrete filled tubes, whole building behavior. Then for steel, we can go for internal and external also. Okay. Then even post fire assessment becomes very important. How much damage has taken place? How will you obtain temperature and mechanical properties of steel? What will be the method of structural repair? Okay. There has to be restriction on the amount of exposed steel set by the building codes. Okay, liquid convention cooling in hollow structural members, encasing the structural steel in brick masonry or concrete. This is done a lot, and plus it also helps in preventing the buckling of the slender things. Okay, so of course, and then the area by volume ratio, that is very important to control so that the fire steel structure heats up, basically how it gets heats up. So that is the also relation. So surface area to volume, that is one aspect. So definitely there are many type of encasements. You can encase it in concrete, you can in various spray applied fire resistant material you can do. Okay, we have already shown some diagrams. Then masonry structures. Okay, so basically, if you're using it for separations, corridors, external walls, so building code will tell how much resistance rating they're required to have. Okay, you can do compartmentalization, fire control system, balance design. Okay, whether the fire resistance is required for exposure on one site or two sites, that's also important. Okay, so there are brick standards, brick size, void area. ACI has a lot of things on that if you want to refer to. Okay, for timber. Basically, it is as far as construction material, it's quick, cost-effective alternative. Very green material also. Of course, we have to ethically source it, but we have to fully understand the risk associated with the timber when we are talking of fire aspect. Okay, so once it catches fire, it will create a hazard to nearby property also. Okay. So fire resistance ratings are available. Timber is available. Wood temperatures, mechanical properties, design concept for heavy timber or members. Then how it goes for timber connections and fire. So many codes are going for these kind of things also, so that even timber can be used in fire zones. Okay. Um, Even separating functions, separating walls and floors, they can be assessed by tests. So these kind of methods are there. Like this is a design procedure, what they are showing, one of the Euro code that is doing it. Okay, so how you have a design procedure, you go for prescriptive rules or performance based code, where in prescriptive you say, okay, this much will be the member proper member, I would say, section dimensions and everything, how much spray area and all, every those thickness and everything. And one is performance based. We go for various how we analyze the member, how it will perform in the fire and everything. Okay. So for single family constructions, these kind of buildings are very common, where timber is very largely used. Okay. So for single family construction, there are various norms which are given. Okay. Even for these kind of buildings which are multi-family, so they're giving various norms what should be done. Okay. Where gypsum board can be used, how they can prevent fire from spreading. So these are all types of things which are available. The details are there, which should be always, referred for wood. Okay. So giving air cavity, thermocol, and everything that also helps. Okay. For floors, they have various things. What kind of rating we are using and everything. Okay. So fire cement composites, uh, non-combustible landscaping. That is also important. Landscaping. Because that's where the fire will spread very easily. Okay. Then even light frame construction is very popular. Okay. So we use many small and closely spaced members that can be assembled by nailing. Okay. So this is very popular in other countries, and where fire is a big issue many times, because of the thick forest covers and everything. Okay. So first the carpenter fabricates a floor, which is wooden joists and subflooring. So then that becomes the working platform on which the frames are then done. Okay. So these are also traditionally used. Okay. And the key aspect is how fire, behavior, resistance, all these things, how will they happen. Okay. So of course, but we have to understand the fire will spread fast. So we have to have supporting stairways, enclosure, which are fire resistant. Okay. So all these are very important aspect. Okay. So if I'm designing for fire, I'm also designing for sustainability. Okay. Because resilience and durability are very important aspects of sustainability. So I should definitely go for fire resistant design. Okay. So with this, I'll stop my presentation.